How many SaaS products do you use at work on a daily basis? Now, I want you to keep that question in the back of your minds as we go along, because it will help contextualize a lot of what is going to be discussed. Now, some of you might be asking, oh, why do I care about SaaS? Well, if nothing else, because it's a major part of the software market at the moment. Like, there are a lot of big players in it, and as probably most of you have noticed in the past 2 years, we had a bit of a global pandemic happening. So a lot of companies were faced with the difficult choice of either opening up part of their current infrastructure to allow employees to work remotely as close as they can as they did back before when they were in the offices, or maybe onboard and use a SaaS product to kind of complement what they're already doing and still keep their current network infrastructure pretty locked down. So, remember, the button goes down. So I'm sure all of you have seen and probably work with these SaaS products, but just for some context, let me give you some numbers to see, why they're such big players. Like Microsoft 365, for example, for the last financial year, generate about $20 billion worth of revenue. Slack as well, hitting almost $1 billion for the last financial year. And GitHub, although not for the last financial year, when it was acquired in 2018, got sold for $7.5 billion, which was about 30 times its then recurring revenue. So clearly, these are all really, really big players. But they're still interesting from a cybersecurity perspective because there's not really that much information out there at the moment on how malicious threat actors target these. In comparison to on-prem infrastructure environments and the MITRE attack framework, which has approximately more than 100 TTPs for just classic Windows environments, SaaS products have about 22. So clearly, everybody's using it, but there's not really too much information on how to secure it. But hopefully, I'll shed some light on that. So, as Iran said, I work on a large variety of cloud security jobs, ranging from small transactional work to more strategic bespoke work, like purple teams, and specifically targeting cloud estates. In general, I love cloud. I love all cloud-related topics because it's cool, it's new, and most importantly, any new research coming out of it does help a lot of people all at once, since everybody's using it. Now, before moving specifically to SaaS, let me kind of discuss a general problem with telemetry and why it's actually so important. Now, telemetry itself is important because no defense is perfect. Like at some point, at one point or another, a breach will occur. It's inevitable because attackers never really stop. They're always going to try to compromise your environment. And as a bit of an example over the last year or so, let me showcase some specific attacks, which I'm sure all of you have heard, and as well as an indicator of how much revenue that company generates, as a bit of an idea on how big it is. So first off, let's start off with the Vastamu hack, which was a pretty bad attack against a company that provides health services. So a lot of patient records were leaked and available on darknet forums for people to buy. And some might say, okay, they're not that big of a company with only $10 million worth of revenue, right? So maybe their budget isn't that big. Well, you've got the SolarWinds hack, which I'm sure all of you have heard a lot about over the last year, which was pretty much the largest supply chain attack in recent history that allowed attackers access on a large variety of both US and international clients for months on end. And one that's pretty much hot off the printing press is the Twitch TV hack that happened earlier this month, which leaked the app source code as well as a lot of revenue numbers for streamers on the platform for the public to see. Now, you can see that these attacks target both small, medium, and large companies altogether. Like a problem in your, like a breach in your defense will happen. So it's important to have adequate logs in order to actually discover when that happens and react accordingly to try to contain it. But what is adequate logging? Well, that's the million-dollar question, isn't it? So the problem is a bit twofold, right? It's when you deviate from the nice middle ground known as adequate logging to one side or another. Now, at one point, you've got where you don't have enough logs, actually, to work with. Now, this results in, obviously, lack of visibility in the components that you're trying to monitor for. Let's take, for an example, Microsoft 365, right? If you're not ingesting Azure AD sign-in logs, you might miss out that a single IP is currently trying to log in to different accounts in your estate using a credential stuffing attack, right? And OK, let's say you've now starting to ingest that. But now, because you're not ingesting, let's say, the SharePoint service audit logs, then you end up in a situation where you can't see that now a single user is downloading hundreds of documents from a confidential SharePoint in your environment at 9 p.m. in the evening on a Saturday, which is not really normal now, is it? Now, but the other side isn't particularly rosy either, and that's where you've got too much logs to work with, and you're not really sure how to go about it. Like, let's assume you're using Google Workspaces, right? And you flip the colloquial log switch on everything possible that you can, which is great, and you're getting all that piped to your SIEM tool of choice. But now, if you don't have actual alerts, proper alerts to work with that logs, you will have the logs, but you're not really acting upon them. And for the most part, it's just going to generate a large bill to your SIEM tool of choice. And I definitely don't envy people using Splunk that end up in that situation. Now, rewinding a bit, let's say you've enabled the logs for everything, but you've also set up alerts for pretty much any possible malicious action that you can think of that might occur in your environment, which is, great, that's super. But then you get to the problem where your SOC team is getting alerts pretty much every second minute of the day that they need to triage, figure out if it's actually malicious or not, and then respond accordingly. Now, this is fine for a certain point, but if the team isn't large enough, or if it's happening too often, that what ends up happening is that the SOC team just starts becoming sluggish, because in the end, they're still human. Like, they can't work 24 hours without stop, without break. So alerts get triaged a bit slower, and triaging might end up, going a bit faster. So potentially, something that might be regarded as a false positive might actually be an actual indicator of compromise. And so you end up with just a lack of visibility there. And why this is an issue with SaaS is interesting because of the way kind of the service model works. So I'm sure that you've all seen this graph in one way or another, which is the shared responsibility graph for as-a-service offerings. So logging on premises is easy, right? Because you've got access to all the hardware that's as a customer. You all know that. So if you do need logging at any point during in your technological stack, you'll likely be able to find the solution on how to get that, right? Then we move on to infrastructure as a service and platform as a service, which now at this point you're kind of losing a bit of control over the underlying tech stack, but you still have access to probably operating system level actions or network controls that you can still set up some logging there. So it's not completely that you don't have control there. But now the disadvantage and advantage, obviously, of SaaS is that you don't really need to manage any of realistically, the underlying technological stack. You need to pretty much manage access. You need to manage basic configuration and how it integrates with your environment, which is good in the sense of minimizing maintenance for your product. But from the perspective of a customer, you don't really have a lot of options on what to log and what to alert on. Obviously, the logging and alerting in software as a service products then pretty much falls on whoever's offering the product to perform logging and alerting on their own hardware, and then allow you to integrate with their solutions to actually get that logs out. And some software as a service offerings, like Microsoft 365, actually allow you a lot of possible logs and alerts that you can set up there because of the various components that they have, and also the various Defender service offerings that add on and help with that. Now, okay, like we figured out, what's kind of the problem. So how do we actually solve this? Now, to start off with, one thing that we do need to make clear is that TTPs differ within SaaS offerings. Now, realistically, you might say, oh, some of the TTPs are pretty similar. And if you look at the MITRE ATT&CK framework, a lot of them do overlap with stuff that happens on premises. But the difference in SaaS is kind of the uncertainty of malicious intent that ends up happening. Because let's say on an on-premises environment, there are some indicators of compromise that are clearly malicious. Like somebody running Mimikatz or Metasploit on a box is more than likely going to be malicious. And if somebody in finances is running an encoded PowerShell command, you're probably not normal. But for SaaS offerings, you have to work with a lot more subtle actions and kind of try to figure out if they are malicious or not. Let's take as an example Alice that works for your company and logs into Microsoft 365 every day and lives in Manchester. So she logs in from Manchester pretty much for the last month, most of the days. But then one Friday, she logs in from an IP that's geolocated to London. Now, is that malicious? Because she might be just visiting friends and family. She might be visiting them on Friday. She's working from home on Friday. So she could have just gone there on Thursday evening, work on Friday, and then continue on over the weekend. Or is it that somebody's compromised Alice's account and is logging in from a server located in London? As another example, let's say a service principal, right? So you've got a service principal that's doing automation in your environment and is deploying resources within your platform. Like that's well and normal, and it's expected that that service principal is likely going to be doing privileged actions. But what if one day it starts actually managing user access? Is that malicious, or has the cloud engineering team just expanded the automation capabilities of that service principal to also manage user access? Like, subtle differences, but possibly different intentions ultimately. So, okay, we've got the gist. So where do we start? Over here. Essentially, when you're doing security for a SaaS offering, you do need to start, at the start when you're still planning on what SaaS offering to use. It's not just enough to focus on, does the SaaS product actually fulfill my business needs? You need to also ask questions of, does this SaaS offering give me enough security controls to ensure that when it gets integrated in my environment, I have enough controls in place to defend myself and enough logs and alerting in place to at least be aware if something malicious is happening. So ultimately, ask yourself questions of, how can I restrict user activity? How can I integrate with my existing SIEM or SOAR solution? Is log data throttled, or is it in real time? And do I need to pay additional fees for enterprise licenses to actually get full control over your telemetry? Because some offerings, even though the team might be fairly small that are using it, sometimes you do need an enterprise license to get full access to log analytics data. So we've started off, we've chosen a SaaS product. So how do we go about designing and threat modeling for it? Well, generally, we can, at a high level, we can follow these general steps. So we start off with making a plan of what type of users will be using this solution. Make a list of the types of users and how they're going to be kind of granularly segregated in terms of access. So which ones are administrative users, which are standard users? Do you need any user levels between them, and so on and so forth. Once you've made a list of that, then start making a list of resources and components within your current environment that SaaS offering is going to be integrating with. This could be your SIEM, this could be your identity provider, this could be any other like analytics tool if you have. Generally, anything that SaaS product is going to be touching at some point in your environment, make a list of it and order it by criticality of the data stored within those resources, because that will then kind of give you an indicative idea of which are the more critical things that that SaaS product might have access to, and then work out next on how you're going to integrate with them. So make a list of whether you're going to be using, let's say, connection strings or credentials, API keys, or are there other ways that you can actually integrate with these products a bit more seamlessly, like specifically in Azure with managed identities. But the important thing is to make a list of all the possible options that you've explored and keep that updated. So then we move on to figuring out threats. Start threat modeling. Establish, what are the actual critical resources that you need access. What are the actual threats, both external and internal, that you need to consider? This should also include the assumption that not only an internal user might be compromised, but also assume that the parent company actually hosting the SaaS might be compromised as part of a supply chain attack. Because as we can see, it does happen. So you definitely need to at least have some plan in mind on how to react if something like that happens and you are made aware of it. Once all that has been kind of sorted out, then we move on to kind of the last, second to last part, which is actually implementing all that design documentation and threat modeling in practice. So actually integrating the SaaS product and making sure that it all works fine. And the important thing here is that if there are any deviations from the original design or threat model, then do please make a note of those and update the documents accordingly, because it does help ultimately, being aware of any changes that resulted due to technological limitations or specific limitations within your platform itself that require these changes. And if you have those documented, ultimately, you can then refer back to them if something, hopefully, doesn't happen. But if something does happen, then you have that clear idea of what's connected to what and how is it connected to. And then as a last part, and as a bit more of a continuous piece, is doing actually security testing of that platform component. So, once everything's implemented, everything's working fine, the team is happy because they have a brand new, shiny SaaS offering to work with, make sure that you do kind of continuous audits of how the whole part of your general environment is working. So assume a compromise of a single user of like different perspectives, and try to do testing to discover what's the colloquial blast radius if a user like that gets compromised. Figure out what can they actually gain access to within the platform, and plan accordingly mitigations and defense in depth, and how to restrict access as much, like restrict malicious activity as much as possible. And also try to use these exercises as a way to also test if monitoring and logging and alerting is actually being effective. Like, do these actions that the security testers do raise up flags? Do they raise up any alarms? And are you automatically preventing some of these actions from happening? But before getting to that point, it's important to actually engineer some detection within the platform. So detection engineering isn't really an easy thing, right? Ultimately, it's, for the most part, it's not about trying to build it all at once, because then you'll likely end up in the too many logs part of the scale. So start off from a baseline and build up gradually, because that will allow you to actually do more adequate logging and keep on top and make sure that you've got kind of minimal false positives and work out the ratio between false negatives and false positives that works best for the size of team that you have. Review how and what logs you're actually ingesting in the environment. And most importantly, find the necessary types of people to build out robust defenses. And this shouldn't just be your blue team members or SOC analysts. And not because they're not competent. I'm absolutely sure that a lot of the blue team security detection engineers and security analysts are super smart people. It's more about a difference in perspective. Because as with a lot of things in general, having people with different perspectives come in to discuss a given problem gives you a clearer picture on how to solve that problem and how to do it in the most efficient way. And in that sense, you need to involve people with offensive security capabilities, as well as experts for the SaaS product itself and how to manage and build it out. And work together to build out this efficient detection. Now, in terms of figuring out how to prioritize, this detection engineering activity does help out a lot, because you can use the created threat model and all the design documentation that we discussed in the slide before the last one on how to prioritize which alerts and what detection to focus on. So let's take as an example, let's say Google Workspaces or Microsoft 365, right? So for vertical privilege escalation activities, before you start moving into detecting and alerting on individual dangerous permissions that get assigned to either a service principal or a user account, it's more important to make sure that any role assignments to super admin in Google Workspaces or global admin in Azure AD does get scrutinized a lot by the SOC team, because usually admins don't really pop up like out of the blue. So any changes to those like predefined roles should definitely raise up some red flags if a new admin isn't set to be onboarded. And let's take, for example, data exfiltration activities. Before you start alerting on like specific keywords or phrases used in documents that are marked as sensitive or secret within your SharePoint, do make sure that you have alerting in place to raise a flag if somebody's downloading hundreds of documents from a given SharePoint at any point in time. Because ultimately, it's important, as I said, to start off from a baseline, figure out what's definitely critical when you want to log and is definitely malicious, and then build out from there, because it gives you a better picture of the whole environment. Now, I know everybody likes examples, so let's do a bit of a tabletop exercise and see how we'd actually do one of these detection engineering exercises. So imagine you're the CISO of a new company called Placeholder that plans to run an online shop for electronic and household goods, right? So it's been brought to your attention that the developers want to use GitHub to store their, for code storage and also for a lot of their CI/CD pipelines. So you're in the process of getting enterprise licenses set up. Now, you've invited F-Secure alongside GitHub SME and a member of your cloud engineering group, which is going to be starting off effectively a bit of a SOC team within the environment, to start building out some detection for this new product. So we begin by analyzing some entry points, right? So after some discussion with the team, we figure out let's say two entry points for now, which is either a compromised user credentials. So these can be achieved either through a targeted phishing attack or, unfortunately, due to credential reuse, like credential stuffing from a breach that has occurred somewhere else. Or let's say an exposed personal access token. So it might be a token that was accidentally committed to a public repository, or maybe an SSH private key instead of the public key somewhere. These things do happen. And ultimately, they do give you some level of access within the environment. So we figured out some initial entry points. So let's figure out some goals. So as a start, let's say an attacker might try to compromise the application code base, which will give them the ability to set up a backdoor within the actual shopping application. They might be able to steal client information right from the start as they're using the app, which is pretty bad. Or they might be targeting the infrastructure code base. So the team will be storing Terraform templates as well as accompanying PowerShell scripts within the environment. So if an attacker modifies those, they can put backdoors within the deployed infrastructure itself and allow you to do lateral movement within the environment and in production specifically. And let's say specifically compromising CI/CD pipelines. So it does this could allow an attacker to modify the different gates and checks that are being done as code is being deployed. Either make some changes to the code from these gates, or maybe even steal credentials that are being used as part of the CI/CD deployment. Because usually with proper secret management, you'd get a lot of the code, a lot of the secrets, API keys, or credentials being passed dynamically as the pipeline is being run. So this is a prime target in order to get some credentials that might be valid for other company resources internally. So, OK, we figured out some goals. We figured out some starting points. So then we sit together in a room, and then we start developing some attack paths, right? So we've figured out a couple of attack paths that the user will do. As an example, let's say if you've managed to compromise an administrative user, then you can use, then an attacker might use that to set up persistence within the environment, set up another account, give it some form of a bit more limited administrative access, just so that it falls a bit under the radar, and gives them persistence even in the case that they lose access to that specific admin account. Or they might change the security controls being configured within GitHub itself to allow them more access or make repositories public and steal code directly. So, all is well. We've now sat down. We've developed some attack paths, some potential points at which monitoring could be happening. So all is well and good, and we've all moved on happily ever after. Or not, because ultimately, like with a lot of things, what ends up happening is that 2 weeks later, you as the CISO get a call from your SOC engineer saying, oh, everything was going great. A lot of the alerts are working as we expected, but there are some that are firing off a lot more than what we initially envisioned. So we're getting a lot of false positives from a couple of them. So you end up having to schedule another call to kind of discuss and go through and try to figure out why this is happening, right? And these are usually the pitfalls that you end up landing into when you're building out detection in general for anything. And it's the same for SaaS products as well. Sometimes you need to figure out how to solve these issues. So let's go through some of them that the SOC engineer has noticed. So taking the disabling branch protection action, right? So the stuff in GitHub that you would like to monitor for is the protected branch destroy and protected branch policy override. So it's all well and good with the protected branch destroy because it's ultimately always going to be generated when you just outright remove any protected branch policy. But the team found out that the policy override thing actually fires off for a lot more actions than you would initially anticipate. So it's not really that useful by itself to figure out if any change to these policies is malicious or not. So ultimately, in order to actually figure out if it's malicious, you need to get data from other events happening in GitHub, maybe combining it with, oh, a user recently got promoted to an admin, and then this event happened shortly after, which would actually help you out figure out if this is just a false positives or it might be an actual real thing. A second type of pitfall might be that you might need data from somewhere else. So let's take the promote user to organization owner, right? Which is a pretty important one. So the action that you need to look for is org update member. So now the team integrated the GitHub audit REST API, sorry. And they do get org update member events occurring once a user gets promoted. But they noticed that the REST API doesn't really tell you what the change was. It tells you that a change has happened, but it's not really descriptive in what that change was. So you end up researching a bit more, and we find out that the GraphQL audit log API actually does have 2 extra fields, which is permission and permission was, that actually tells you what the previous permission was and what the new one has been. So now it turns out that you need to integrate both the GraphQL and the REST API together to combine all the possible fields from them and figure out what these changes were. And now you have a bit more visibility on when somebody gets promoted to an organizational owner, and figure out if that has actually been sanctioned by somebody, or maybe somebody's being a bit naughty in the environment. And then as a last kind of pitfall that can occur is, let's say that it might need integration with an entirely separate API altogether. So as another example, the promote user to repository admin. So after a bit of investigation, the team sees that the audit log API doesn't actually tell you that that has happened at all. So you're a bit confused, but then you start researching a bit more, and you find out that there is actually a separate API that you need to hook into using a webhook and query it at the repository level that will actually tell you when somebody has been promoted to a repository admin. So now, in addition to the GraphQL and REST API, you need to now consume a separate webhook that's querying the repository events to see any actions code edited for that repository and see if a user has had their permission changed. So, oh no, now after sorting out some of these pitfalls, the team is much happier. The false positives have been reduced as much as possible. And now everybody's actually happy. The SOC engineers can finally take a breather and focus on actual threats to their environment. Now, we started off with a question. So now let's kind of end on another rhetorical question. So generally, on a scale of 1 to 10, like how confident are you in the SaaS detection that you're doing at the moment? Essentially, I want you to remember a couple of things from this talk, 3 specifically. One of the takeaways is that SaaS is really unique in the sense of how critical the data it might hold is, and how little control you actually have over the hardware as a customer. Second one is that realistically, efficient detection in SaaS products is something new. It's developing. There's not that much research out there on it at the moment, but it definitely needs more looking into and more investment both from providers themselves and their clients to actually make some efficient login and alerting. And last one is that you definitely do need to find members with the right set of mindsets and like perspectives on the topic to enable and create efficient alerting and logging within your platform.